Guys, welcome to this video, and in this video I'm going to discuss how can you implement simple linear regression in Python. So what you need to do, first try to import all the libraries. So we'll just return all the libraries that you want to import, and we are using the Colab for running the code. You can just go to the online type Google Colab, and you can just do a lot of coding in Python machine learning using the Colab. Colab is a good because a lot of things related to the data science libraries are already installed in the Colab. And as we'll progress through the course, I think at the end we will see like how to write modular code or write the code such that it can be run on the cloud as well. So first of all, what we want to do, we just want to import the libraries. Once we import the library, just try to click on this particular icon. It will run this particular code for you. First time if it's running the code, it will take some time, but yeah, it will run the code for you. And there is one of the other alternative to run the code. And just what you need to do, just press shift and enter from your keyboard all together, and it will also run the code for you. So once the code is run, we can see that we get a tick sign here, and this tick sign indicates that the code is run successfully. If some error is there inside your code or inside the block that you are running, the error will be just flashed down the block like here. Once we call our useful libraries, what we need to do, we just need to load the dataset. So there are two ways to load the dataset using Google Colab, especially the dataset that you have. The first thing is that just click on this particular folder icon, and what you can see there is a upload icon. So you can click on this particular upload icon, and you will get Windows file for you, just your local file. You can just go to the download section. So I have just have the data in the download section. I will try to upload the data in the download section itself. This is the salary data, and once you upload the data, it will just be available for this particular session only. Once you just close the tab and just come again, just run this particular file again, it will not find this data because this particular data is available only on the current runtime. But if you want to use this particular data set using any particular location, what you can do, you can just upload this data set on the Google Drive. And once the data is in your Google Drive, what you can do, you can just mount your Google Drive on the Colab itself, and you can access any files on the Google Drive by just specifying its path once you have mounted the particular drive. Now what you need to do, once we have uploaded the dataset is itself available in the root directory. So that is why I just written the name of the files only, and there is no need to write any path because once you upload this dataset here, it is available in the current root directory. Let's say if you are uploading a lot of folders here, just you need to follow the folder structure, and just you will get the dataset. So once you run this particular code by pressing shift and enter together, you will also get a tick sign, and it means the data is successfully imported. Now what you need to do, just write data.head. We use data.head to just get the first 5 instance of our dataset, and this way you will just have a better idea about how your data looks like. It's a very small dataset, but yeah, in general this particular things is used to see all the columns and first 5 rows for the data. So once you run this, you will see the data.head, which is actually the first 5 rows record of your data. Now similarly, there is options for data.tail where you can see the last 5 records. So this is the very basic, because using this you can see the last 5 record of the data. Let's say you want to see last 10 records, then what you can do, just write 10 in this particular function, and it will give you last 10 records of your data. Similarly, you can also write 10, 5, any numbers in the head, whatever the size of your data is, and you can see the lot of data in the head itself. Now we use data.info to just see some basic information about the data. So if you just write data.info, you can see that there are 2 basic things. First is year of experience, and second is salary. So these are your 2 columns. Now you can see that it is a null count because this particular things have 30 values. So the data set here of size 30 rows and 2 columns, 30 cross 2. Okay, and this particular data set have no any null values, like all the data has been available, so there is no any null or missing values. What to do in the case of missing values, we will try to discuss in the upcoming lectures, but just try to first in this lecture just focus on what is the simple linear regression, how to implement it. Now once we get this particular things done, we want to see some basic statistics about the data. So what is the basic statistics about data? So just like mean, median, their standard deviations, their count, their maximum, minimum, all of these values are together called the basic statistics about data. So in Python, to get the basic statistics, there is a very simple function called data.describe. So once you write data.describe, it will give you a lot of basic statistics about data, and just you need to interpret these statistics in your term. Like you can see that the year of experience, the total number of data is the 30, so this is the count basically. The mean means the mean year of experience in this particular data is 5.3 years. So like whatever data we have got, the mean year of experience, or you can say that the year of of experience has average of 5.3 years. Now a standard deviation is 2.8 years. The minimum is 1.1. Like whatever data you've given, the minimum of the particular value is 1.1. Like some people like at least 1.1 experience have with someone in this particular data set only. Now we have 35, 25%, 50%, 75%. So 25% is called the first quartile, and the 50% is called the median or second quartile, and this particular 75% is called the third quartile. So this particular things also you get. So what is the value of first quartile, what is the value of second quartile, what is the value of third quartile. So you can see the 4.7 is the median of year of experience. It means that if you just take your data set on the single line, 4.7 years, half of your data set is going to lie in this particular set, and half of this your data set is going to lie on the above 4.7 years. So similarly for maximum value, where maximum year of experience is 10.5 and maximum salary is 122,391. So this is maybe in the dollars or rupees or whatever the amount is, but this is the basic statistics for data. So there are only two variables here, but in general, when you will see a lot of variables, the thing is that you will try to find a lot of things related to the data set. You will try to interpret these things meaningfully, like these are the year of experience, something like that, so that you get a valuable insight about data before fitting the model. Now if we just go ahead and see how to plot the point. So like I told, the data set is only 30 cross 2, and only two variables are there, x and y. So we can easily plot this particular data set on the and see what this particular data set looks like. So just first see what the data set looks like. So this is the data set that we have, and you can see that we actually there is a very nice linear relationship actually happening between this point, and you can see that approximately a line of this kind will be able to estimate the these points approximately. So we'll just try to fit the line also and try to plot the line also, but just for the sake of now, just let's understand what this code is all about. So before moving to the code, just let's understand this plt.figure. So plt just we have used for matplotlib, and we are just making a figure size of 12 cross 6. Then we are using pair plot. So pair plot means just you need to give the data, your x variables, what is the x column and what is the y column, what is the size of the point, and what is the kind of this pair plot is. So this is a scatter plot, means that these are only dot 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 plot. So you can see that this has given us a nice plot of the data. Now we are just using x level as here. So x level you can see here, and y level you can see as the salary that we have also added. This is the years, and this is the salary that you can also add using the plt.x level and plt.y level. Then you have plt.title, which is salary predictions. So this is the salary prediction, this is plt.show, which actually show the entire graph. So this is a very nice kind of relationship. Now what we'll try to do, we'll try to fit the model, but before fitting the model we actually need to separate our x and y. So we know that we want to model year of experience versus salary. So let's say I'm giving a year of experience as 2.5. You need to predict what is the salary based on this particular year of experience. So what we do for this, we just separate out x and y. So you know, like whenever you import the data in the pandas or the panda data frame, let's say want the data of any particular column, what you need to write, just write the variable data, and just inside the double square bracket write the column name. It will give you a separate data frame of this particular single column, and this will give you a separate data frame for this y column. So this particular thing, once we done, what we have x and y. Now before moving to the fitting the model, what we'll try to do, we'll try to just use trend test split. So what is this trend test split? Trend test split is actually used for dividing your data set into two parts. One part is actually used for training, and one part is used for the testing purpose. So let's say here we have taken the ratio to be 80-20. So your 80% of the data will be used for the training, and your 20% of data will be used for the testing. So this is actually a nice practice, because once you have the whole data, once you fit the data on the training data set, you want to see how the data set actually behaves on the test data. So this is a very nice practice, and what you need to do, you just need to import train test split from the model selection. This is one of the popular libraries, and once you start taking a lot of working on a lot of data set, you will be actually able to remember all these functions by yourself. But nevertheless, you can always find these functions on the internet, and it is the best practice to find the internet on the internet and just get the right code. Once we use this particular trend test split, what you need to do, just write here x and y, whatever your x and y is, and your test size, like how much amount of data you want as a test data. So here I specified as a 20% of data, that is why you need to write 0.20. Random state is something that we use to replicate the same randomness again and again. So this is not a thing to worry right now. So once we just do the trend test split, it will give the output data in the following fashion. So first is x trend, second will be x test, then it will be y trend, then it will be y test. So similarly we have written the variable name to store the results of this particular function. So once you get this particular result, x train and x y train you can use for the training data, and x test and y test you can use for the testing data. So what we need to do, we just print the same of the data just to see how the data set actually looks like. So I told you there was 30 observations, so 80% data in the training data, and only the 20% or the 6 data is in the test data. So it is pretty much good to just give a glimpse of how the linear regression works. So start running this code from this particular point, and I think I forgot to run. So just start this running all this code and we'll get the output. Okay, once we just do train test split, we'll get the shape of all those particular data set in this following fashion. It is also important because we just want to see if the x trend and y trend has the same shape or not. So that is why we actually do this. So before now we can actually now fit a model. So there is two way to fit a model using the Python libraries. One is called a Statmodel. So this is also a popular library for machine learning, specifically if you want to go more toward the statistic side. And the second is called sklearn. So sklearn more is the toward ML implementation. Statmodels is good for regression time series because it will give you a lot of insight about your model that sklearn will not be able to give. So we will try to fit this model using the Statmodels and see more insight about our regression model. So what we need to do, we just first import our library as import Statmodel API JSM, and when just import this particular library, what we do, we can now fit the model by just calling this particular variable JSM. Now we know that we have only two data, x and y, but our model is something like y is equal to a plus bx. So we will need to add this particular constant. So what we do, we add sm.add constant. So what it does, it just append vector of 1 with y. So this is your updated this is your updated x data, and once you have this updated x data, you can now fit this particular data into linear regression. So what you need to write, just write sm.ols y trend first, then x, and then dot fit, call the dot fit method. So what all these things mean, just let's start understanding step by step. So OLS means that ordinary least square that we discussed in the last slide. So ordinary least square method, because this is the method we use for calculating our linear regression equation or estimating the parameters. So now this y trend is what we have got using x trend trend test split, and this x add c is equal to the final x that we have after adding the constant, and then we use dot fit method. So dot fit to actually fit the model. So once you run this particular 2 line of code, you can see that your model is fitted, but you won't see any result, because to see the result, what you need to do, you need to do model.summary. So once you do model.summary, you will see a lot of summary about your model. So we'll just understand this particular thing step by step. You can see that here you have got a lot of results. So like you've got r square adjusted r square that we have discussed. So I will discuss the formula in the next upcoming slide. You have got the log likelihood also. You have also got the probability of statistics, which actually is approximately equal to 0, which indicate that the model is significant. Now coming to your variables, you can see that here you have a lot of different results for that. So like for the constant, the estimated coefficient is 25320. Okay, and for your year of experience, the estimated coefficient is plus 9423.8 something and x. So this is your final model that you have got, and this model actually you can use for predicting the salary based on the given x. Now we can also see there is a standard error associated with all these things. Then you have the t statistics, the p value of the t statistics, and their confidence interval. So these things are also important. So I have not discussed these things in detail, but in upcoming lectures I will show you and going in depth of the simple linear regression, like why do you do this hypothesis testing, why this p value is, what this p value is all about. But just for the sake of understanding, just understand that if this p value is greater than 0.05, then it means that your variable is not significant. So if whenever you fit the model using OLS, sm.ols, and you see a lot of variables, and whether you see p value of greater than 0.05, it means that variable is not significant. You can remove those variables from the regression, still get the same, approximately same result. So this is the basic statistics that you get after fitting the model using OLS sm.ols. Okay, you can also print r square, adjusted r square separately by just calling the model, because this is the variable where we stored our fitted model, model.r squared, model.r square adjusted. So these are the keywords that we actually leverage from the Statmodel library. Now one more thing that you want to see is just the how your fitted line looks like. So this is what I have just plotted. So this is how your fitted line looks like. So these blue colored are the test data, so these are the test observations. Okay, and these all these blue point, and this green are the training data, and these red lines that we're actually seeing is the best fitted line. So you can see that a lot of point actually lie on the from training data actually lie on the line, but a lot of point also does not lie. But this is the best fitted line using the method of ordinary least square that we get by minimizing the squared sum error. Okay, so this is your this is how your model looks like after fitting the data set. This is pretty much the same code, but what we actually trying to do, just give me a small glimpse of this particular thing. We are just using this linear regression for sklearn libraries, and we are actually plotting this particular things in the line fashion by using the plt.plot. So this it gives you the red line, and once you get the red line, you can also print the coefficient that is actually pretty much same that we got from the sm.ols. Now you can also make predictions on the test data. So what you need to do, just add constant on the test data using model.predict. Just pass this particular variable, because our x test already have x and some 6 observations of x, and just what you need to do, just add 1 1 1 6 times. So these are the constant, and this is x1 x2, these are the test data. So once you pass this particular thing in your inside into the predict function, it will give you the prediction result. So what I have done, I have just concatenated the results in the same thing, and just I have plotted the like how this particular things looks for the test data. So you can see that for 9.6 year of experience, the predicted value is something close to 11,15,790, but the real value was 1,12,685. So 1,15,000 is, I think it's a very close to the real data set, and obviously it will not be 100% accurate, but it will be somewhere close to the test data, the real predicted data, and that is the thing that you want. So our predicted value should be approximately or as it is equal to your real time data set that you have collected. So this is why we just predict on the test data. So we can also calculate the test error. So like from sklearn matrix, you can import mean squared error, and just if we just calculate the root mean squared error, because we have already done the root. So the RMSE for test RMSE for this particular model is equal to 7,059 rupees. So I think this is a pretty much good model, because you are able to predict the salary of the people with experience, which had just being variable by 7,000 rupees, and it is the approximate error of whole model. So this is, I think, best way to see how your models looks like. So in this particular videos, I explain how to fit a model. Just load the data set, then get the basic statistics, plot the line, and then train test split, then fit the model, and then actually you can predict the result, and obviously you can calculate the RMSE and other metrics. So it's not always be the simple, because in the real time data set we get a lot of variables, but soon we will be able to see how to deal with the large variables. So thanks for watching this video, and let's meet in the next video.